everyone, welcome to our chemistry. So as I have told you, there will be one schedule. The schedule will be like that. First chemical kinetics, then we will go for next important chapter, nitrogen compound, alcohol, aldehyde. Then we will go for the another chapter and the small chapters also, environmental chemistry and adsorption, these things, and coordination chemistry, and we will cover up all the chapters in 6 weeks. The whole thing 8 chapters we cover in 6 weeks. So our topic is chemical kinetics. Basically, maybe from semester one, when I have discussed about semester one, that time I have seen one of you are commenting that very less amount of questions, very less. Of, the thing is not like that. Less number or more number. The thing is like that. The probable type of question means what type of question may come that I am discussing here, and related to that question that you have to do, that you have to practice, that you have to predict. Suppose I am discussing one question, you change the number, you change the value, and you practice. And you go for, suppose I am discussing for one tough question, then you have to take the another, suppose the reciprocal of that graph may come. So this probability I am discussing, not how, not all the type, all the question, not this type of thing. If you get the type of the question, which equation to use, then you can get it. Otherwise, it will be like that for like semester one. Once you get the whole concept, see the question, what type of question, what will be the, which equation we have to study, which equations are important. According to that equation you go. So like this I have taken few questions here. So as I can't make the video too long, so that's why I have taken few questions, but I have tried to take the type of question, variety of questions. Okay, so without wasting it, okay, start. So here, slope for first order reaction, the plot of ln R versus ln R versus time. So for first order reaction, as we know, reactant is equal to reactant concentration at any time equals to initial concentration of the reactant e to the power minus k t. Now t is the time. Now we can write ln A equals to ln A0 minus kt. So we have to draw the plot taking ln A, means here ln A we can consider as ln R, because A is equal to R. A is the reactant concentration. A is the reactant concentration. Then ln R versus time in this plot. If we take ln A in the y-axis, time in the x-axis, so minus k will be the slope. So here the slope will be negative with the intercept ln A0. Here slope will be equals to minus of k. Then we are having for zero order reaction. For first order reaction, next coming for zero order reaction. For zero order reaction, the equation we know. For zero order reaction, A is equal to minus kt plus C is the constant. So at time t0, t equals to 0, this is the initial constant. A into 0 equals to C. So C will be equals to A0. That means A minus A0 equals to minus kt for zero order reaction. Now, if we want to plot here ln A versus T, so here we have to get ln of the equation. Okay. Okay, and for zero order reaction, the R versus time is reactant concentration time. Taking reactant concentration as y-axis, we will get minus k T plus A0. So C will be the A0 will be the intercept, and with minus k, K will be the slope, and T is the time. So for zero order reaction also, it will look like here we are taking A concentration, here we are taking time, the slope minus. So the difference is here we had to take for first order reaction ln R versus T. Here we have taken only A or R versus T, the slope. From this type of question, any blanks, any MCQ, or that numericals also may come. For an elementary chemical reaction, 5A plus 3B2C, the rate law expression is. So this one is also a very, very question. So we can write the rate law in various ways. So when we are following the first way, the first question seen one way we are following, and here we are also following another way to write the rate law using rate constant. So once we are having 5a plus 3b to c, so if it would be a normal reaction, not an elimination reaction, then we can't say what is the order. But as this one is an element chemical reaction, so the order we can say the molecular, the order itself, rate equals to rate constant, concentration of A to the power 5, concentration of B power 3. So what is the rate now? Yeah, let's see where is the option A to the power 5 and B to the power 3 option. C will be the correct. Going for the, it's a very interesting question. Here it is told how long will 5 gram of this reactant take to reduce to 3 gram. First order reaction rate constant is given. Here it is told in gram format that initial concentration of reactant was 5 gram. Now after some time, after time t, suppose the the final concentration, or at time t, concentration of reactant become 3 gram. First order rate reaction rate is given 1.15 to 10 to the power minus 3 second. So we have to find out the time required. As we know, time required is equal to 1 by 1.15 10 to the power minus 3 ln initial concentration 5 by the remaining concentration A0 by A, remaining concentration of the reactant is important. So the reactant take to reduce the 3 grams. So already remaining concentration as 3. After calculating this, we get the time, calculate it and write it in the comment box with how much time you are getting. And I think you will get the time in the proper unit second, because rate constant is there in second. Let's go for the next question. Okay, till now it was some short type of observation. Now I have taken one numerical based calculation. The question, as you can see, the following data where some data are given. This reactant A, reactant B, and here's some rate of the reaction with change of reactant A and B. Here the question is asked, find out the order with respect to A and B. Once we will get the order, suppose with respect to A, the order we have assumed that X. Suppose with respect to B, the order is Y. Write the rate law and overall order. So the rate law we can write in the format of rate equals to rate constant, concentration of A to the power X, concentration of B to the power Y. And the overall order will be equals to X plus Y. Calculate the rate. Then taking any one of the data, we calculate the rate. Okay, let's start. First, we are having that we have changed A, concentration of A, from 2 to 0.2 to 0.1. Let's take any two value where we have kept fixed concentration of A, or we have kept fixed. No? If we go for fixed concentration of A, here this value 0.1 and this value 0.1, that the serial number 2 and serial number 4 take the same concentration of A, whereas varying concentration of B. So if we take the if we write the rate law like this way, rate equals to A to the power X, B to the power Y. Suppose rate R1 is the rate corresponding to equation A is equals to, have got 6.0 into power minus 3. That will be equals to rate constant A to the power X and E to the power Y. Here A is given as 0.1 and B also given as 0.1. Okay. Then next go for the rate of equation 4. So I have written here R2 equals to 2.40 into 10 to the power minus 2, that will be equals to rate constant into 0.1 for X and 0.4 for. Let's divide. Let's put that one as equation 1, this one as. Let's divide equation 2 by equation 2 is divided by equation 1. We'll get 2.40 into 10 to the power minus 2 divided by 0.6 10 to the power minus 2 equals to zero point 0.4 by zero point 0.1 for y. As we know, 10 to the power minus 2 minus cancelled out. Then we are having 0.6 and 2.40, so that out by the 4. Here also it 4 equals to 4 to the power y. So y equals to 1. So the order of the reaction with respect to T is y. With respect to T is 1. Let's go for the calculation of x. For calculation of x, we have to keep the consideration of B constant. We want to take consideration constant. See the experiment 1, experiment in the experiment 3, consideration of B is constant. So here the equations are, we can take as 4.2 10 to the power minus 2 first. 4.2 10 to the power minus 2. So see, we are having 4.2 10 to the power minus 2 this rate, and here B is 0.3, concentration A is 0.2. Another is 1.68 10 to the power minus 1, where B is 0.3 but A is 0.4 in concentration. Okay, we have put all the three and we have got here the same B that will get cancelled out, rate constant also, and here 1.68 and 4.2. Can write this as 0.42 to 10 to the power minus 1 divided by 1.68 10 to the power minus 1 equals to 1 by for x, and 0.42 and 1.68 by cancelling them we will get, by dividing we will get 4 1 by 2 for x equals to 1 by 4 and x equals. So the rate of the equation with respect to A will be 2. So let's take that. Let's write. So while writing, we say rate equals to rate constant, concentration of A square, concentration of B to the power 1. So this will be the rate. Now if we want to know the rate constant, what we will do? We will take any one of the equation. We will put A value, B value. Suppose we are taking equation 1, the experiment 1. We will put A value and B value 0.2 and 0.3, and we will put rate as 4.2 minus 1. The rate. That's simple. So our next question is, a first order reaction is 50% completed. And how much time would it take for 90%? It will be asked how much time would it take for 100% complete. For first order reaction, of course, for 100% take finite amount of time. A first order reaction is 50% completed in 1.26 or 40. Now for first order reaction, 50% complete means the T half is as T half is given as 1.6 10 to the power 40 second. So K will be equals to 0.693 by T half, that is 1.6 10 to the power 40 second. Now you have to calculate it. If you want to get the all answer, you join my Telegram channel. I will share the answer paper there and you can check it. Or you can comment in the comment box also. How much time would it take for 90% complete? T we have to calculate, and that will be equals to 1 by K, and K we will get from this value. Ln, the initial concentration was 100. After 90% completion, 10 amount remain for reaction. That time we have put the K with what we have calculated from this value. Okay, let's see the next question. The next question is given as the value of rate constant of decomposition of carbon at 30 degrees centigrade. If we take T1 as 30 degrees, so 30 plus 70 Kelvin, so it will be 303 Kelvin. So at that time, the rate constant K1 is as 3 into 10 for 4 second. Calculate the temperature. Calculate the next temperature T2, at which it will be 7.5. It will be 7.5 into 10 for 4 second inverse. As we know from our Henke's equation, A is equal to the exponential factor or minus A by R, where E is the activation energy, R is the gas constant, the temperature in Kelvin. So here if we take 2 L K value, so we will get ln K2 by K1 equals to minus K by R 1 by T2 minus 1 by T1. Let's put T2 T1 in temperature unit. So T1 is given as 303 Kelvin. T2 we have to find it out. EA is given as 20 kilojoule per mole. As we are putting R value as 8.314 joule Kelvin inverse mole inverse. So we will take activation also in unit, that is 20 10 joule mole inverse. Okay. So we are having minus K by R minus 20 into 10 to the power by 8.14 into 1 by T2. 1 by T2 1 by T2 means 1 by 2 means 1 by T2 because T2 is not given. Which values are given? K1 is given, K2 is given, T1 is given here, EA is given here, T2 we have to find it. So we can calculate on the answer. Next, show with the help of graph how does rate constant can be. What we are having? A is A per minus K by RT, and take ln K equals to ln minus A by RT. So if we plot ln K, the y-axis if we take and 1 by t the x-axis, get a plot with negative slope where slope will be A by R and the intercept will be ln A. This plot with the variation of rate constant with temperature with the Arrhenius equation. Why the molecularity of a reaction cannot be zero? Molecularity means how many molecules are colliding. So how many molecules are colliding means the molecules, the number of molecules that are colliding. That will be the molecularity. So if no molecule is colliding, if molecularity is zero, how will we get the reaction? That's why molecularity can't be zero. Okay. Next question we are having, half lifetime of first order reaction is 20. What will be the rate constant? Very easy question. Half lifetime given means T half is as immediate. So what will be the rate constant? Will be of course 0.69 by 20 minute inverse. That's the answer. Find out and comment it what answer you are getting here. Okay. Next question we are having another. What will be the rate law for a reaction where AB is reactant? By doubling A, rate becomes double. By doubling A, rate becomes double. By doubling B, rate becomes 4 times B. So you do the solve the question, and as your homework you can take and you comment it, so you can test yourself also and see that you know what you are getting and where you are getting. Then I will try to take more question and I will try to take more doubt clearing classes. So for this, that much only. And if you like that video, please like it, share with your friends, and don't forget to comment and forward.